All right, January 2019, question 3b. And it says this. The diagram below shows a right angle triangle with sides A units, B units, and C units. Using the diagram, so I, using the diagram A, express C in terms of A and B. All right, so let's do that part first. So I A. All right, so let's just go back and look at the triangle a little bit. This is a right angle triangle. C is the hypotenuse. All right, and one way to express the hypotenuse in terms of the other side is Pythagoras theorem. Pythagoras theorem says that the square of the hypotenuse is equal to the sum of the square of the other two sides. So from Pythagoras theorem, I can say that C square is equal to A square plus B square, where so C is the hypotenuse and B and C are the other two sides of the triangle. Um, Pythagoras theorem says that the square of the hypotenuse is equal to the sum of the squares of the other two sides. Therefore, C square is equal to A square plus B square. So that is the answer to IA. Now, IB says, write in terms of A, B, and C an expression for sine theta plus cosine theta. So B, first of all, sine theta. Now, this is our angle theta here. All right, that's our angle theta. And the side A is opposite to theta, and the side B is adjacent to theta. All right. The side that is opposite to an angle is the side that is in front of the angle. All right. So A is opposite to theta, B is adjacent, and C is the hypotenuse. Now, sine is equal to opposite over hypotenuse. So the sine of theta would be opposite A over the hypotenuse, which is C. The cosine of theta, now cosine is equal to adjacent over hypotenuse. The side adjacent to the angle theta is B, the side B. So this is B over C. Now, therefore, sine theta plus cosine theta would be equal to A over C plus B over C. All right. So we're asked to write in terms of A, B, and C an expression for sine theta plus cosine theta. II says, using the results from IA and B, show that sine theta square plus cos theta square is equal to 1. Alright, so we're to show that sine theta square plus cos theta square is equal to 1. So I'll start by saying that sine theta square, similar saying sine square theta, would be equal to A over C square, which would be equal to A square over C square. Cosine theta square would be equal to B over C square, which is equal to B square over C square. Now, therefore, sine theta square plus cos theta square would be equal to a square over c plus b square over c square, all right, and this would be equal to a square plus b square over c square. But from Pythagoras theorem, remember we said that c square is equal to what? A square plus b square, that's here. So this is Pythagoras theorem. All right, so from Pythagoras theorem, c squared or a square plus b square is equal to c square. So I can bring that to bear here to say that this is equal to c square over c square. Pythagoras theorem, the square of the hypotenuse is equal to the sum of the square of the other two sides. So the sum of the square of the other two sides, which is a square plus b square, is equal to the hypotenuse square, which is c square. And c square divided by c square is equal to 1. So therefore, sine theta square plus cos theta square is equal to c square divided by c square, which is equal to 1.